So we are now going to go ahead and take a look at a part in Rhino, and we'll take a look at how we can establish the coordinate system origin. So I have a part that's imported into Rhino, and this was imported as a step file format. You could be working with a native Rhino files, or you could be even working with files that could be imported into Rhino. Now, as you can tell here, the part that's imported in here could have been designed and exported out from an assembly. So the part is way out in space. So typically when the part is designed, you wouldn't be designing way out in space. You would probably be designing somewhere closer to the origin by picking one of the planes or one of your, the seaplanes or the construction planes. Since this may have been part of an assembly and exported out from an assembly as a part, the parts could have been, you could have applied some mate relations and to basically establish your assembly. So the part could have been out somewhere in space when it was exported from an assembly. So we would like to machine this individual part. In order to machine this part, we would need to first establish the orientation of the part to be suitable to our machine tool. So we need to perform some transformations in here. So we could use some CAD transformations to perform this. As you can see here, the part needs to be rotated and also oriented to the XYZ orientation of your machine tool. Now, the difference between RhinoCAM and Visual CAD/CAM in terms of representations of the machining coordinate system and the world coordinate system, the toggles are right on the machining browser itself, as you can tell. So the machining, currently I have the machining coordinate system visibility toggled on. I'm going to toggle it off and display the world coordinate system first. So the world coordinate system is displayed as a triad, where the red arrow represents your x-axis, the green represents the y-coordinate axis, and the blue represents your z-coordinate axis. And by default, your machining coordinate system is coincident with the world coordinate system. If I toggle the display of the machining coordinate system on, you will notice that a second set of arrows appears right on top of the world coordinate system. So the length of these arrows, as I pointed out earlier, for machining coordinate systems are slightly longer or larger compared to the world coordinate system. That's how we can easily identify and differentiate between the world coordinate system versus the machining coordinate system visibility. Now, this is also true in the case of Visual CAM for SOLIDWORks, the way these machining coordinate system and the world coordinate system triads are being displayed. So the world coordinate system is at the coordinate system of the design coordinate system in your Rhinoceros. Your XYZ origin is where the world coordinate system is being displayed in RhinoCAM. So once we have this part in here loaded, we would like to perform some transformations so we can orient the part. So I would like to orient this particular face so I can look down looking through the part from this particular face. One of the ways or one of the techniques I could use for orienting the part in Rhino is using some of the transformation tools. I could use transform, orient, and I can use orient using 3 points. I'm going to use the orient using 3 points feature in here. And for the first point, I would like to pick a midpoint or a center. I'm going to pick a midpoint right in here. I'm going to pick this as my origin, which would be my x, y origin, the intersection of the x and the y coordinates. And I'm going to define my x-axis vector right in here. I'm going to pick this as my midpoint, or I could even pick this over here, depending on how you want it to be established. And for the y-axis, I'm just going to pick a point right in here. I can snap to an end point or a near point. And now I'm being prompted to select the target points to be oriented to in Rhino. So I'll just go ahead and pick 3 points: the origin, x-axis vector, and the y-axis vector. So in this particular step, you will notice that the part was oriented or transformed using the transformation tools in Rhinoceros, using your host CAD system. So you can use a combination of different tools to orient this part in here. So this is one of the ways how you could perform the transformation in CAD using transform, orient, using 3 points. There could be several other techniques or other ways to do it. I just chose one of these ways using 3 points, similar to how we did it in Visual CAD/CAM. So now we can tell that the part is oriented. Now if I go back and perform an undo on this operation in here, I'm going to undo this. So you can see that the part is back the way it was imported. And now we'll show you how we can also use the tools that are available in the CAM interface, where you can go to the program and under setup you'll find orient part, and now we can use a similar technique what we did in Visual CAD/CAM, where we can use align to and then select the surface, and we can pick this surface in here, the face. You can see now the z-axis is being normal to this particular face. You can use that and then pick OK, and this will also orient the part. And now if you need to flip the part over, you could go back into orient part, and you can specify a spin angle. I could use 180 degrees, and I can choose about the x-axis, and you can pick OK to orient the part. So this will basically flip the part over by 180 degrees on the x-axis. You can also use additional transformation tools to orient the part in here as well. So once you have the part transformed and oriented, you could then go back and establish your origin by using set to part. I could choose highest Z, southwest, so it'll automatically locate the corner coordinates of the part based on the bounding box of the part, and it'll place it at the XYZ origin in here. So you could use a combination of different tools using the transformation tools in Rhino and use the transformation tools under orient part in RhinoCAM to orient the part to the desired orientation, so the part is in the intended orientation of the machine tool to be able to program it.
Today, I want to interject here a couple of things. One of the attendees pointed out that the surface orient command using surface that you just did, you did that in Visual CAD as well as in RhinoCAM. One of the actions you did in Visual CAD was actually to explode the solid model, while here in Rhino you did not have to explode it. And I just wanted to explain that in Visual CAD, when you select the solid model, we cannot select a surface of a solid model, so there's a limitation on Visual CAD. But in Rhino, even though you might have a solid model, you're able to select an individual surface of the solid model. That was the first point I wanted to add. And the second point is, one of the things that Uday did was he said a combination of transformations. One is using the CAD transformations tools, and then the second thing that you could use is the CAM transformation. I wanted to point out the difference. The CAD transformation tools only work with the geometry that you're machining, or the part geometry, while the CAM transformation allows you to transform both the part and the stock together. So if you've already created the stock model, then it's much easier to use the CAM transformation tools, because it'll not only transform the part geometry, but also the stock geometry. So that's the main difference. So you might want to consider that in your choice of the tools that you're using. Thanks, Uday.
Thank you, Joe.